That's a lovely introduction, thank you. I first want to acknowledge all of you for coming. What a wonderful thing. I'm quite emotional about it. I started with this in 2000 when I met a young man, and I'm going to talk to you about it. Detect, protect, and enable. So this was Ben. Now, a terrible thing happened in June 2001. He was warming up for a game of hockey, and he dropped down dead, and he couldn't be resuscitated. Now, the story was that he'd had this history of epilepsy. He'd been diagnosed with epilepsy during his life. And when I sat down with the mum, she'd been referred to us because there was a professor of pediatrics who happened to be a couple of doors down and said, "It doesn't sound right, John. He died with epilepsy." So I saw them in the clinic, and they gave me this story of a boy who'd had a near drowning and always had his collapses related to exercise. And I thought, I wonder if this is long QT syndrome. And long QT syndrome, well, it's a condition which is named after the ECG, which has got sort of four or five phases in it, P, Q, R, S, T, and the QT interval is just a time interval on the ECG. And this is some examples of what they look like. Now, that's the arrhythmia you get when you drop dead. Basically, the heart wobbles very fast. It contracts so quickly that it's not able to eject blood. And, of course, you can have a seizure. And this had led to what I thought was a misdiagnosis in Ben, that he was not epileptic at all, that, in fact, he was having a rhythm problem and then was going on to have a seizure. Now, it turned out, I arrived in New Zealand in 1998. And in 1995, 1996, this was an era when genes were being discovered that cause long QT syndrome. A wonderful piece of work. So I had this young man, his picture in front of me, and I wondered if it was possible to get hold of some of his DNA. And we got hold of his Guthrie card from many years ago. That's the neonatal screening card that's kept. And they got the family's permission. We managed to extract it from there. And a little bit of DNA was extracted from one of those spots. And the clever guys at Lab Plus made a genetic diagnosis of long QT type 1. So this was really the first thing that set us off in this direction. I started to get more and more people coming into my clinic where there'd been a sudden death in a family member. And we managed to find the Guthrie cards of 23 of these people. And we found that 39% of them, 9 of them, had actually had long QT syndrome as a cause of death. Now, so that meant we could go back to these families who'd been told they died from this or that, or they didn't know why, and we could give them some closure. Like, I don't have to blame myself anymore, was the sort of comment I was getting. Also, of course, it meant that there may be other people at risk. But surely this is rare. Surely this is a rare phenomenon. Well, it turns out it isn't. So I did a look through the child-youth mortality data in 2002. There were 36 sudden cardiac deaths I could find in 1 to 24-year-olds. I'm sure there were more. But the remarkable thing about that was 2/3 of those were unexplained. And there was a good couple of studies from New South Wales which looked at the prevalence of this sort of sudden death in 1 to 35-year-olds. And it's about 20 per million per year. So that's about 90 per year in New Zealand. So who is at risk? How do we find these people who are at risk, and how do we protect them? In 2006, I teamed up with Cure Kids, and we had a plan. And that plan was to set up a national study looking at sudden death using the molecular autopsy, as we call it, the genetic testing in the deceased, to see if we could find a cause of death on a population basis. It was the first study of its type in the world, and we found that around 1/3 of the time we were able to find an inherited heart disease, something that ran in the family as a cause of death. So 30% or thereabouts had an inherited heart disease. So that was the national screening program of all sudden deaths. Since those results were so emphatic, the Ministry of Justice, then the Chief Coroner, Neil McLean, got it. He realised this was important, and we were the first country in the world by a long way to have a government-funded molecular autopsy service. It's been funded by them since 2008. We form a productive partnership with the Coronial Service and the National Forensic Service, and this is part of the literature that they provide to people who've had this terrible event. Of course, if you find one person, you can find many. And these are just 2 of the families from the registry. All of those red dots are people who've been found, as it were, out in the community, pre-symptomatic individuals who've now been found at risk. You find one, you find many. We do that not only with genetic tests, but also with heart tests, ECGs, exercise tests, things like that. How do we do this? Well, we have to have a coordinated, multidisciplinary approach. And we have 3 main coordinators so far in New Zealand: Jackie, who's the national coordinator, Mandy, who coordinates from Waikato, and Tom, who coordinates from Wellington. We give out a simple message for doctors: detect the probands, that's the first person in the family, refer them to the registry, and screen the family. And we have these protocols at each of our hospitals. And here you can see on this slide, for example, if there's an unexplained cardiac arrest, refer to CIDG. An unexplained, dilated, poorly functioning heart, refer to CIDG, and so on. So we have some simple messages that we're giving to our colleagues in the hospitals. We also have a website, which we just mentioned earlier, which has forms and protocols for our doctors, and it's an information portal for families. So are we being successful in our plan to detect people in the community? Well, yes, we are. We've shown that in Auckland City, we've already detected half of those who we expect to have long QT syndrome. We know this from population ECG screening programs that about 1 in 2,000 people have long QT syndrome. Well, we've found 1 in 4,000 already in Auckland. So it's pretty effective. And this is the highest detection of long QT in the world. There are, of course, other cardiac inherited diseases. There's other electrical ones like long QT syndrome, Brugada syndrome, CPVT. You'll be hearing a bit more about those later on. And there are muscle disorders, hypertrophic cardiomyopathy and arrhythmogenic right ventricular cardiomyopathy. Lots of names and lots of letters. They're pretty frightening terms, but they mean a lot to the people who've got them. Fortunately, there is stuff we can do about it. Now, in March 2006, when you saw that picture of that young man with the Cure Kids banner behind him, that was me, by the way, 56 genetic diagnoses and 170 individuals are registered with CIDG. Now we've got 740. So how do you protect these people? Well, it's simple. It's quite simple. You have to avoid some medications. You have to avoid some triggers. For example, we might tell people, perhaps you shouldn't go surfing out there in the ocean, because if you have a momentary loss of consciousness out there, that might be the last chance you'll have. So you won't be resuscitated out there. Beta blockers, once daily medications, usually free of side effects, tolerated by hundreds of thousands of people across the world. Keyhole surgery, sometimes for those few who can't tolerate beta blockers or have a high risk, we can do this little keyhole procedure through the armpit, leaves hardly any scar, and it cuts the nerve to the heart, so it reduces the effect of adrenaline on the heart. Defibrillator pacemakers, we're going to hear more about those. And these protect you. That's a site on the bottom there. You can see an ECG rhythm of an abnormal rhythm, abnormally fast. A little shock comes from a defibrillator pacemaker situated inside the heart, shocks them back into a normal rhythm. But of course, we're giving all these messages to people who have inherited heart disease. Don't do this. Don't do that. You mustn't do that. You mustn't do the other. But we're all of us, as well as being cardiologists, we're human beings too. We want to enable our patients. We don't want to just restrict them. And there's been gratifyingly some good research looking at how much we can enable people. We don't want our kids to get fatter and fatter and blob in front of the TV. They're only going to get the complications of obesity. We don't want that. And we don't want little Johnny sitting on the sideline, unable to partake. If at all possible, we want to help people get back to do what they want to do. There's been some good research in this, and this is a study from the Mayo Clinic, which has a big registry of long QT syndrome. In a cohort of 130 athletes with long QT syndrome, they continued to participate in competitive athletics. That's not just any old athletics, that's competitive athletics. There was just one cardiac event in over 650 athlete years of follow-up, and that was one boy who wouldn't take his beta blockers with a severe form. Sorry, that's very small there, goodness. In that other series, there were no cardiac events at all. This is just published in the Journal of American Cardiology. There were no cardiac events and no deaths over a long period of follow-up in long QT children. So it seems if they take their beta blockers and avoid certain medications, they can get out there and can continue doing stuff. What about those people who've got ICDs in place? Here's some ICDs in infants. We can put them in young children, even in adults with complex heart problems. There's now good evidence from multinational registries that many athletes with ICDs can engage in vigorous and competitive sports. So we don't need to restrict many of our patients. Some of them still we do, but most of them we don't. What about those who are actually sort of a relatively low risk overall, but take part in the occasional high-risk activity, like they want to go for a swim? Well, here's a mum watching somebody anxiously swim along the pool. Advisory external defibrillators. These are marvelous things. They work very effectively, and we're going to hear more about those. And so some of our families now, what they will do is they'll have an advisory defibrillator with them when their child or their brother or their partner undertakes some sort of high-risk activity, be it swimming or athletics or whatever it is they do. So these are small things that can fit into a handbag and go along with you. If we have a policy of having advisory external defibrillators, then that means we can also start protecting that 70% of people who are going to have a cardiac arrest where they don't have an inherited heart disease. Clearly, even if we screen everywhere, people are still going to die or try to die. We want to catch them, if we can, and give them a shock and bring them round. We're going to hear more about that. But if we put advisory external defibrillators everywhere, then they will save lives. And these AEDs put into schools, they tend to resuscitate more of the parents watching than the actual kids themselves. So detect, protect, enable, is that it? Well, I don't think so. If we're lucky, we're going to be looking at cures. And this is really quite exciting now. It's going to be a decade away, I think, possibly more. But we're getting close. This is a very exciting piece of research from Italy. CPVT is one of those conditions which is highly lethal. It's a monogenetic condition. It's just one gene that does this. If you can correct that gene abnormality, theoretically you can cure the patient. Well, in Italy they've created a mouse model of one form of CPVT. They've injected viruses with the correct genetic imprint in. The viruses have gone into the cells in the whole of the mouse and cured it for life. Very exciting. We're trying to make a difference. Thank you very much.